Hello there. I've been recently working on an LLVM code gen backend for my compiler project for a custom programming language I'm building called FAE, F-A-E. And I want to talk about it because I find it interesting and I want to talk about it. So just as a quick introduction, here's a quick little FAE program. There's lots of things yet to be implemented in the language, so some of this is less ideal. For example, this printing is a little awkward. It'd be nice to have a proper printing/formatting facility built into the language or some variation of that. So this could be simpler. That's not been built yet. It'd be nice to have plus equals yet here. That's just something I've overlooked so far. And this iteration should ideally be some sort of range iteration, but that's fine. Let's run this real quick. So I just invoked the compiler, which loaded this example program and the 4-file standard library and compiled it and generated a file, which is currently dynamically linked to libc, glibc in this case specifically. At some point, it would be cool to not have to rely on a libc. I'm not that concerned about it because lots of things you need to interop with need you to probably interop with libc, because if something, lots of things expect you to be using the libc allocator for objects that you're passing back and forth. So I'm not really that concerned about it, and on most of the time when you're building anything more complicated than just basic file I/O anyway, you're going to need to be dynamically linked to some stuff anyway, like graphics drivers and stuff like that. So I'm not that concerned about that. So yeah, let's just to show that here's what it's printing out right now, and I can run the executable itself, and I can come over here and let's make this -10 and build and run that, and we can see the output change, and I can build the executable, run the executable, and that's changed. And I figured we start off by just writing a little something in here because that's interesting, and we could talk about the complications and difficulties of building the LLVM backend along the way. I started on the LLVM backend because I needed something longer term than generating C code, because that gets very gross very fast, and also it's quite slow. But also the work I was doing on building a custom code gen backend wasn't going to show fruition for a while, and I needed an LLVM backend anyway, because the goal of the custom code gen backend is really fast iteration times at the cost of basically no optimizations. And so I don't really want to build an optimizer up to the snuff of LLVM right now. So I need an LLVM based backend anyway for final shipping executables anyway. So I figured, why not just do that now, so that, because it's going to be a lot less work than continuing to work on my AMD 64 assembler, which you're seeing bits of it right now. And I can pull up the tests. And it would also be good experience of working with calling conventions and stuff like that while doing something simpler, and it's a lot harder to screw up. Still pretty easy, but a lot harder to screw up, and a lot more visible what is happening when you do screw up. So good experience, and if something I need to build anyway, it would get me to a better place faster, so I did it. So what I was thinking we could do as a little test program, because I just added while loops, so finally the language has flow control that's more than just recursion. I thought we could write some sort of greater or lower sort of game or something like that. So in that vein, I figured we'd start off by figuring out how to, well, first of all, generate a random number. Right now, the language is little more than a front end to C libraries, because there's no standard, I haven't written any standard library yet. The language isn't there yet anyway. So we're going to write this quite like a C program, but we're going to have a little bit of niceties on top. So I want to say libc rand. Cool. I just want to see the int. Excellent. Okay, so we're going to say it's I32. So I'm going to go here to libc, and we're going to add a thing for that. R. So put it down at the bottom. I was alphabeticalizing it in my head. We'll call this rand as well. And it returns an I32. We might as well implement the srand while we're in here, because why not? So srand goes below. Cool. And then the seed has type unsigned int. There we go. Cool. And I know we're going to need to be able to read. So libc read. File descriptor. Buffer count, and returns assigned count. Excellent. So I'm going to put that below this, because alphabetical order. Read. So these are all using the libc, not the libc, libc. These are all using the system C calling convention, which on this case is the AMD64 sysv ABI, which was non-trivial to implement, I have to say. So we're going to call this read, and we have a file descriptor, so I already have that there. That might not quite be the argument we want it wants, but we can figure that out one thing at a time. So we have a buffer, so we'll say buffer is a pointer to U8, and then a U size, because that's size T count, and it returns an S size, so it's an I64, because I don't believe I have an I size in the language right now. Let me double check that actually. I size, U size. I don't believe, actually, what am I doing? Primitive, numeric type kind. I do not yet. I will have to do that at some point, but we're gonna say it's an I64 for now, because that's fine. So, and let's make sure the compiler is happy with that. I'm dumb and wrote that the wrong way around, because I was reading C code. Cool. So the compiler is happy with that. And you can see we have nice error messages. And you can see the parser attempted error recovery and emitted more errors afterwards. So what we want is first of all, our random integer. So I'm going to move this over here. This over here, just for reference, is the LLVM IR output by the compiler for this program. Now that I've made this basically empty, we can see, yay, it shrink. There's main. No, it doesn't do anything, but if I bring back that logic, now it does a lot of stuff. Look at that. But right now we just want our random numbers, so I'll say let number equal, actually let's put this in a function. And we have order independent functions, so play round, sure. And I can say play round. And so we could hypothetically like put a loop around this. Do we want to do that? Yeah, because we'll put our confirmation code out here in main. Cool. So play round, we'll say let number equals our rand. And so that's our I32. And we now need to read the user's input. So let's use, I don't want to actually use I haven't imported these things, but that's fine. I don't want to actually use the printing helpers I have, because if I go into std out, I have a whole bunch of helpers that just call printf. And I don't really want to use all of these right now. I will actually, now that I think about it. I do want print string because string literals in Fay are currently defined as being null terminated for the ease of use of just like passing to C functions, but I don't want to have to think about that. So I will use print string, and I can just like stick a new line in the string literal, it'll be fine. And it'll still be only one call. So I want printf, and I want rand, I want read, and I know I'm going to need at some point, actually I might not even need printf, I'm not sure. We'll see about that. I know I'm going to need the, is it A to I? A to I. I want the C version. Let's see. Thank you. I know I'm going to need A2I. I don't like using these sorts of functions, but we need to be able to use what we have at our disposal in the meantime of not having formatting or parsing code in the Fay standard library, which I just added loops. So like now it's finally possible to write this stuff, but it doesn't exist yet. So we want A at the top. So we'll say extern A to I. A to I. And so that takes in a string. And returns out our int. There's also long and long. We'll also do those. We'll also do those. Because while we're in here, we might as well. A2L. This can be our I64. And then we have our, what is it called? LL. Excellent. So that's our long. I don't have longs. So I don't need to worry about that. I believe a long is an I64. No, I'm silly. Minimum bits. Right. Because technically these things are different, and I just care about at least 64 bit. Yeah, okay. To the compiler explorer, because I only care about what is defined to on my platform. Basic 64-bit Unix. Int main void, and so I want, I'm just looking at, I want to look at size of. Actually, I'm getting off track. Let's just not do that, and I will look at that later. I know that's that. I'm gonna say that that's correct, and move on with my life. So we have our random number. We can say print string. We can say guess the random number, and I just realized we actually need to make sure that this is from 1 to 100. We actually need to, I don't have modulo. Is there a modulo function? That would be really convenient right now. No. Let's continue on pretending we moduloed that. To do, add modulo to the language. Okay. Guess the random number. You'll never guess it because it's within the I-32 range, but that's fine. So while, so I don't have break yet, so mute break equals false. While break is not true, we'll say print string, and we'll print out a little prompt with no new line, and then we need a buffer. And so unfortunately the language does not have empty arrays right now, so we're gonna have to do this manually. So we can say let buffer equals, and we need usizes. So this is the cast syntax, and array literals infer their type from the first value. So I want 10. So I'm going to say this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, important to note, I said this is immutable, but I'm going to be modifying it because right now as a stopgap solution, this doesn't actually have any type of like an array. Like this would be like 10 U8. This doesn't exist in the language right now. Instead, this is a slice. It's actually a mutable slice. So even though the binding is immutable, it's a pointer to mutable memory, which is a little unfortunate. That's a to-do. So we want to read our stream, which is going to be our standard in. I'm going to assume that that's correct. We can double check that with C in a moment. So we'll say, we'll put that over here, std in. And I want to say that let std in equals std in that. Do I want to do that? No, I just want to do that. This is the reference operator. And I want to give it the buffer, which is buffer.pointer. That gives you the pointer to the underlying data. There's also pointer.len, which gives you the length of the slice, because these are first class slice types. Pointer, and then our count is 10. And we need to remember that this is not null terminated. This is going to be kind of terrible. So actually I want to say 9. And so we want to say let red bytes equals that. I'm going to assume that if red bytes is less than or equal to 0, we'll return, because that's fine. And then we can A to I that. So I want to say buffer red bytes plus 1 equals 0, just to make sure there's a null terminator there so A to I doesn't get confused, because we're unfortunately working in C land, which is a little gross, and I would rather not, but we haven't built the abstractions yet because the language is brand new. So let's go A to I. And we want to pass in that string, so it's just buffer.pointer. And we know it's null terminated. And then it returns out our guess. Let's just make sure the compiler is happy with that. No, A2I in scope, because I didn't import it. That would help. Yep, those are in alphabetical order. Excellent. Compiler is happy with that, and we never looped. Did we never loop? Why did we exit? Ah, that's why. So what we'll say, we'll say that equals 0, and then we can go in here. While red bytes is equal to 0. I'm not sure if VS Code will be smart enough for me to do that with this not having a language technically set. So we'll do that, and then If red bytes is less than 0, return. How about that? Collapsing from integer with a non-integer read bytes. Ah, I did a goof. So this is I64. There we go. That's a compiler bug. It basically means that I created a variable with an unknown integer type. And the compiler didn't actually catch that, which is strange because I swear I added a check for that. But anyway. So that's not... Oh, no. Well, it doesn't equal that. Ah. Well, it equals that. I see. Interesting. So if I do that, why is that? Because we're looping this one, but we should be looping in here. If I just say, well, true. Well, that doesn't exactly flush, now does it? We should have a flush. Part of it possibly is that this is wrong. Oh, no, there's F flush. Okay, so I know that standard error, we have standard out. And then flush, I'll just put that right here. And that takes just the file. So that's literally just that. Cool. So now I can come over here and say flush. We need stood out. And now does that print our, no flush because I didn't import it. No, it was before printf. No flush. Oh, right, it's F flush. Thank you, LD, or that's actually LLD. Guess we're in number. Okay, there we go. Excellent. So while red bytes equals 0, and we're looping again. Very odd. I would not expect that behavior. So we know the flush is working. Is standard in not happy? So let's write a testing C, and we can come down here, and we'll say, yeah, we probably have it in scope. Read stand in. No, say let. No. 8 buffer is 10 and buffer 9 for red bytes equals that. All I'm actually really care about is that. So I can go over here and I can say clang emit LLVM. Do an split. Okay, what? Read, what header are you in? Really? How very random. Whatever. Cool. Aha. That is our problem. Libc restood in. No, that's standard in file number. And how do I get? Oh, I'm silly. Read can be, where's read? File descriptor is an I32. How about that? And it's just 0. It's just 0. There we go. Yay. Out of range of slice with length 10. Reads up to 9. Oh. Ah ha 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 ha. Because index versus length. Yeah, okay. If you write too much, that's fine. So let's just take a look at our guess. So you guessed and this is guess, and now printf here is very interesting because that is the I'm silly. String literals in Fay are slices, so you have to get the pointer out if you want to pass it to that. 52. You guessed 52. Excellent. Now, vargs are a little annoying to implement because if we look, if I pass a float, and we'll say let float f32 equals 4, just the number 4, and Fay handles this because this 4 is compile time known, and it can figure out how to represent that as an f32. And if I run that, it's fine. But if I do something that like can't be represented as an f32, it'll yell at me, which is very cool. But we'll say that's just 4, and I want to pass that float just to demonstrate something. So I'll say 5, and we get the float. But if I come over here into the IR, we're passing as a double to the f32, and we're floating point extending it because all floats have to be that are less than the size of an f64 have to be passed as an f64 widened at the call site, and all integer types, including Boolean, that are less than 32 bits have to be widened to 32 bits, which was a little annoying to try to find, but it worked. It worked out. So now we have printed our guess, and we can say if guess is less than. Now, are those different types? This is an I32, and this is also an I32. Our number is also an I32 because it's rand. If guess is less than number, print string too low. New line. If guess, if you'll notice, I don't have else yet, so we don't have else. Print string too high. Important to note is that you see we have escape characters in strings. That's something the compiler actually has to think about. If guess equals number, print string. Somehow you got it. And then we can return. Cool. And we can say 55, which is too low. Oh, we're still printing this. And you can see how we're getting some undefined behavior. Fun. 5, too low. Let's say 9999. Too low, 99999. Too low. Gee whiz, I wonder why. And at this point, we're running out of characters. So I can come over here. This is 10. Let's say 20. This is going to be 19. Too low. Interesting. So we're getting some A2I shenanigans now. Anyway, so that's the compiler doing some stuff. This is probably just C shenanigans. But in the meantime, I'm very happy with, oh goodness gracious, look at that IR. But yeah. My next goals are if else, breaking from loops, continuing to fix bugs in the compiler. We didn't even touch generics in this demonstration. And then unions, enums. Methods and private fields on structs, which we didn't even get into structs or generic functions or anything, which are all in the language. But yeah. Alrighty. See you around.